Hello, and thank you for joining this session. My name is Brice Pele, and I'm a mobile specialist at AWS. I work with customers on their mobile application and front-end application development. I'm also a pretty big basketball fan, and we're right into midst of basketball season. One of the things that I love to do is going on basketball sites and checking basketball scores, NBA scores, college basketball, because I don't really have the time to watch all the games that are on TV. So I'll typically go on one of these sites, pull up the scoreboard, and let the scoreboard run and update over time to get the live updates. I do this on a couple of sites. I have my favorite sites. I'm sure you have yours. And I've noticed a couple of things as I've looked at those sites. The first thing that I've seen is data overload. These sites tend to fetch a lot of data just to provide the core experience to their users. And I'm not talking about analytics or ad data, I'm really just talking about core basic data that is needed for their customers. And that is usually due to the fact that these websites or applications are using legacy REST-like APIs that are pretty inflexible. They tend to return all or nothing, so there's not much of an option. They get all of the data that's requested and they can't do much about it. The other thing that I've seen is constant polling. So these sites and applications provide live updates. So you need to refresh the information often enough for it to make sense. And these websites work in a pool model where they constantly request information from the backend servers. So you can imagine that that is pretty taxing to the front-end application, but to the backend servers as well. Then when you take into consideration the data overload and the constant polling, that tends to lead to bad network usage. So you have a lot of data that is repeatedly being requested. And so this makes it difficult for developers to actually implement the solutions that they want. They've got to now think about how to provide the best experience in different types of scenarios, in different environments where they may not have great network coverage. You also have to think about the fact that for a lot of users, data is a commodity, right? You may be in an environment where data is fairly expensive, or you are in a remote situation, and you want to make sure that you provide data at a reasonable rate and consume it at a reasonable rate. And then when you are on the go, let's say you're on a mobile application on a mobile phone, this can lead to pretty poor battery efficiency. So you've got websites, applications that are constantly polling, getting a lot of data, and that have to stay on so that they can provide those live updates. It leads to bad battery life. And at the end of the day, all of these issues not only lead to poor user experience, but it also leads to poor dev experience, developer experience. Because developers now have to spend a lot of cycle worrying about those issues, instead of focusing on the features that really make a difference for their customers. Right. Instead of focusing on innovating and iterating at a quick pace, they have to think about fixing those issues. So there's got to be a better way. And I think that using GraphQL as a data API can really solve a lot of those challenges. So there are a lot of different techniques and tools that you can use to move from a REST-based API to a GraphQL API. And what I'd like to do today is talk about services like AWS AppSync, framework like Amplify and the Amplify CLI, along with GraphQL transformers, and services like AWS Lambda that can help you not only upgrade your REST API to GraphQL, but also upgrade your applications and upgrade your user experience. So let's dive into that. To get us started, let's jump into a demo. So I'm going to pull up an application that I built. It's essentially a React application. It's built with Amplify, with AppSync. It uses GraphQL. So it's running on my local machine. I'm going to log in, remember my username and password. So it's essentially a dashboard. You can see here that I'm showing information about NBA games. And I'm showing information about today's games. I can go back in time and show information about previous games. I can go forward and see the upcoming schedule as well. So you can see that the Blazers are playing tomorrow, the Heat, the Suns. The way this is implemented, this information is actually coming from a data API that's provided by the NBA. So it's a public API that you can access to get that information. But I have fronted that API with my AppSync server. So I'm using an HTTP data source to front this REST-like API and to gather the information before sending it back to my clients, to the application and to the users. One of the benefits of doing that is that I can actually parse out the information that is not needed before returning it to the end users. So for this dashboard, I really do not need a ton of information. I just need the name of the teams, some information about the scores, and then I can return that back. Now, at the same time, one of the things that you've noticed is that we are showing repeated information about the teams, right? And that information is fairly static. So while I am fronting the API to get the scoreboard, one of the things that I've done in this application is that I've actually saved the team information in a DynamoDB table. So when I'm pulling the information about the scores, I'm not pulling the information about the scores from the HTTP data source. I'm pulling that information from a DynamoDB table. So I'm actually accessing two different data sources in one request. So the information that you see here, the name of the teams, and the codes that I'm using to fetch the logos for each team is actually saved in a DynamoDB table. And AppSync allows me to do that, interact with multiple data sources in a single request. To show you how we can use this, I can come back here and look at this scoreboard. And you see that there's a couple of stars in front of the teams. One thing that I'd like to do is select which are my favorite teams so that when I look at the dashboard, my favorite teams will appear first in the scoreboard. And so I can do this here easily. For example, there's a couple of games going on today. They haven't started yet. But one of my favorite teams is the 76ers. So I'm originally from Cameroon, so I love Joel Embiid, so I want to follow the Sixers. So I can start this team, and I've saved that information. It's backed up by a DynamoDB table. I also like the Raptors. Pascal Siakam plays on the Raptors, so I've got to follow him. And I can save that information here. So as I've done that, the information is now saved in my DynamoDB table. If I go back and look at several games, you can see that this information shows up as I'm pulling other games. So this information is saved into table, and I'm just correlating the information that is saved in one table with the information that is coming back from a scoreboard. So accessing multiple data sources at the same time. Now, this is a scoreboard, so I'm sure that one of the things that we want to do is actually display live information. So we can actually go ahead and do that. There are no games running right now, but we can actually simulate how we would do subscriptions with this dashboard, even though the scores are coming from an HTTP data source. So what I'm going to do here, I'm going to open my console. I'm going to clear some information, and I'm going to start a script, Lambda function, that is actually going to generate some live information. So as you can see here, scores are starting to update. You can see, for example, here, the Hawks, the score just moved to 110, Spurs to 102. I'm not doing any polling in this dashboard. The information is coming directly to my application thanks to a subscription that I've started. We can start this again and see how this looks. When I move to a page, I start a subscription, and you can see the log information here. Start score subscription, and I start getting updates for all of the different scores. As I moved off to a screen that is not today's scores, I stop my subscription. So there is no need for me to actually request that information if it's not if it's not today's date. And I can control that through the subscriptions, starting and canceling subscriptions. If I go back to the date, I can see that the information is live. It's being updated automatically. It's coming through subscriptions. So there's no polling. And then just imagine the impact that this can have. If you have a subscription that's visited by thousands or hundreds of thousands of people at a time, there's no more polling and pinging to website, to API server to get all of that information. So hopefully this gives you a bit of an idea of what you can do with GraphQL and how you can upgrade your API to use GraphQL and to provide a more efficient experience to your customers and to your developers. So let's switch back to the presentation. So we talked about GraphQL, but what is it? What is GraphQL? So GraphQL is essentially a data query language for your API. GraphQL allows you to interact with multiple data sources while using single queries. If you compare it to a REST API, when you typically use REST, you would have to do things like if you, for example, we have a blog here, and you wanted to get information about posts, comments, and authors, you would have to do multiple requests to post, comments, and authors. This is not very efficient, especially if you have a lot of information to retrieve. With GraphQL, you have a single endpoint that you interact with, and you can request multiple data types to be returned in your request. You can also have multiple data types and resources living in different data sources. So you can use the data source that makes the most sense for the data type and for your application. GraphQL is a language for your APIs, as I mentioned, and is made up of a couple of components, starting with a schema. A schema is essentially the definition, defines the types that you want to use and that you want to interact with. To interact with those types, you use a couple of operations. You have queries that you use to get and list data types. And if you want to make changes to your data types, you have mutations. So with mutations, you could create, update, and delete data types. GraphQL also introduces the concept of subscriptions. So subscriptions is what provides the live update, and that allows us to subscribe to changes without having to do a lot of polling on the back end. So that's the query language, but you do need a runtime to make it work. And that is what AWS AppSync does. AWS AppSync allows you to build scalable application on a range of data sources, including those requiring real-time updates and offline data access. AWS AppSync is a fully compliant managed service for GraphQL. If you have a GraphQL schema today that is compliant, you can get started in a minute using AWS AppSync. It allows you to connect to data sources in your account, and it supports multiple data sources like DynamoDB, Elasticsearch, Lambda, Relational Aurora, RDS. And it also supports, like I said, offline capabilities and real-time capabilities. You can use AppSync as a GraphQL facade for any AWS service, so it provides a lot of opportunities there. You can use it for conflict resolution, and AWS AppSync is implemented with security in mind. So it has best-in-class security and works well with IAM, Amazon Cognito, API keys, and your own OIDC providers. So one of the things to remember is that AWS AppSync is a fully managed service. It's essentially serverless, and that means that there is no servers for you to provision or manage. AWS AppSync takes on the burden and all the heavy lifting so that you can focus on what makes your applications great. AWS AppSync takes care of the scaling based on your usage and makes sure that it's highly available and fault tolerant. Additionally, you never pay for idle. You only pay for what you use, so it's pay on demand. The Amplify framework is made up of a couple of resources that allows you to build front-end application quickly. It's made up of a CLI, client resources, a console that allows you to do continuous deployment and hosting, and pre-built UI components that you can get quickly started. For example, it provides you with components that allows you to do authentication, just like the one that you saw in the demo that I provided. That was a pre-built UI component. And it has toolchain and JavaScript framework support to help you get started quickly and helps you with lifecycle of your backend resources. Specifically today, I want to talk about the Amplify CLI. Like I said, it helps you create, update, and delete cloud services. So you don't have to spend a lot of time trying to figure out how to create those services and how to map them to your front-end application. It helps you manage multiple environments, so it helps you work with teams. And one of the things that we'll look at today is the GraphQL transform. The GraphQL transformers allows you to write a schema and provide directives that directly map your data types to data sources in the AWS cloud. It also allows you to, provides a GraphQL code gen capability. So if you're doing work on Android or with Swift and you need code generated based on your queries and GraphQL mutation, it'll help you do that as well. So let's talk a little bit about REST and GraphQL. So I mentioned earlier that there's a couple of options, a couple of techniques that you can use if you want to move from REST to GraphQL. So what are those options? So the first thing that you could try to do is replace your legacy REST API with GraphQL API. That is what I did in my demo when I moved the team information away from the REST API into DynamoDB with data types that were mapped to DynamoDB table. Now, if that is not possible, you can also front your existing API with GraphQL. That is what I did in the case where I was retrieving the scoreboards directly from the existing REST API. So I fronted the REST API with GraphQL, and that allowed to provide better experience to my users and to my developers, allowed to accelerate the rate of innovation and implementation on the front end while not having to deal with the challenges on the back end. Additionally, for certain scenarios and use cases that are a bit more complex, you can call existing APIs or data sources with AWS Lambda. In either case, it helps to understand the anatomy of REST APIs before we get started. So what is REST? REST stands for Representational State Transfer. It's essentially an architectural style for APIs. So it provides guidance on how to interact with resources in a backend. It describes how a server exposes resources to clients, resources being one of the key concepts behind REST. It's also defined by a set of constraints. For example, REST APIs have to be stateless, so you don't have to provide historical information to retrieve current information, and they need to be cacheable, among other things. Most common representational format is JSON, the most commonly used. So when you have a client interacting with a server, the client will do a resource request to the server, and the server will transfer back representational state in a response. Like I said, it can be JSON, it could be another format like XML. Here is how a REST request breaks down. You have a method. A method typically describes what the intended action is, if it's meant to be a read type of action or a type of mutation. You interact with your endpoint, your primary API domain endpoint. Then you have a path that exposes different resources, things like post, for example here, or comments, and it kind of indicates the type of resources that you want to interact with. You can also have optionally a query string that provides more information on how the data is to be retrieved. And then you have the headers. The headers indicate things like the content type. So is this a JSON request? Am I providing XML? And you can provide headers can provide other information, for example, like authorization information. So you can provide bearer token, basic tokens, digest, or even SIGV4 information that tells the server how to handle the request. And then into body, you can provide the data that you want to exchange with the server. And the type of the data is essentially determined by the content type entity header. So when you start mapping this information to GraphQL, this is some information that you can use to do that. So if we look at the method, the most commonly used methods are get, post, put, and delete. A get essentially maps to a query. So you would create a query field in your query type to interact with your GraphQL server. You then have post, put, and delete. Those are typical mutations. So for any type of post action, put action, or delete action that you have, you can replace that with a mutation. And then you have polling or WebSockets, depending on the implementation. And that is where you want to use subscription. You want to use a subscription type and register for those notifications. When you look at the endpoint, you want to replace your endpoint with an API. So here what you can do is create an AppSync API and replace the endpoint in your application with the AppSync GraphQL endpoint. And that is available to you via the console, via the CLI, or via the AWS SDK. Then in your application, you can use the Amplify libraries or the AppSync SDK to easily interact with the endpoint. When you start looking at the path, you want to do the following things. Identify the resources, collections, and connections into path. These resources are going to map to data types in your GraphQL schema. You can then use transformers to easily create types that are backed up by data sources. For example, you can use the model transformer for DynamoDB-backed models. You also want to identify custom methods and controllers at the end of the path. For those use cases, you can use a key transformer to create index queries. You can also decide to write custom queries and mutation to handle those custom methods and controllers. On the header side, you can include your custom headers in the API, either at the API creation time, so that those headers are sent with every request that is sent to your GraphQL endpoint, or you can provide headers with every mutation or query that is done. If you are using headers to do authorization, you can look at using AppSync's authorization and authentication features. For example, you can use the @auth transformer to really narrow down which type of user has access to the resources in your data API. And then onto body, for post and put type of actions, you can map the body data to operation input parameters. Let's dive into this a little bit more. So when we talked about identifying resources, collection, and connections, this is what it would look like. So let's say here we have a couple of examples of paths that we may see with a REST API. We have things like posts, post/ID, and post/ID/comments. So that points out that there is possibly here a post type of resource that we want to interact with. There's also a connection between comments and posts. So a post can have multiple comments. So what we're seeing here on the right side is how I could use Amplify transformers to create a post type that is backed up by DynamoDB table. So this would be my equivalent with Amplify transformers in AWS AppSync. So I create my type post and I provide the @model directive. Like I mentioned, that's going to map the type directly to a DynamoDB table. It's automatically going to provision the table, create the table, and create the resolvers that interact with the table. I also create a comment model. And then I create a connection between the post and the model. This is going to allow me to access my comments from every specific post. So here we see what is generated for this type of schema. We get a get post query where I can query for individual posts using an ID. And we get a list post query as well, where we can just retrieve a list of posts. Let's see how this works. I can then write a query, I call it get, and I call get post. I provide an ID, and then in my selection set, I specify the exact fields that I want returned from the query, which is another strong point of GraphQL. I can specify exactly what I want to get back in my query. So here I specify ID, the ID of the post, and then I specify that I want to get back the list of comments associated with the post. So what's going to happen here is that my query is going to look up all of the comments that exist that are associated with the post based on the existing ID. This is all done automatically because we are using the @model transformer and the @connection transformer. Let's look at what we would do to review the path for custom actions and controllers. So there's a couple of examples here. For example, we have post by author, and then we have a query string that specify which author we want to get the post for and how we want to sort the post. And then we also have post/ID most recent comments. So this is REST-like. Most recent comment is not really a resource, but it is a controller action that specifies how we want to get back our data from the backend. So let's look at how we would implement this with Amplify GraphQL transformers. The first thing we want to do is introduce the key transformer. So the key transformer is going to create index queries that we can use to query data based on specific indexes. What we want to do here is query for posts based on the author. So we introduce a field in our key transformer, the first one being author. And then we want to be able to sort by the created @ field after we've retrieved the post that belong to an author. We then specify the query field, post by author. This will get the post by author field added to our type query and will allow us to use this as a query to retrieve the information. I also introduced the @auth transformer, and I introduced a rule that states that only the owner of a post can access a post. Essentially what happens is that every time we make a query for a post, there is a check done to make sure that the identity of the current requester matches the owner of the post. I then introduced a sort field in our connection for the comments. So we had the connection transformer used in the previous slide. The difference here is that I introduce a sort field to make sure that every time we retrieve comments for a post, they are sorted by the created at time. So let's see what this gives us. First of all, we get the get post by author query. And this allows us to get a post by author, as you see here. I can get a post by author and I specify my name. I want to get a post for Brice. And then I can specify a created at input parameter and state how I want to filter down this information. So here I'm essentially saying, get me to posts for Brice that are created at after 2019 January 1st. So it's essentially going to get me everything that comes after January 1st. And it's going to sort everything in a descending order so that when I get my list back, I get the newest post first. And then again, I can use my selection set to specify exactly what I want to get back. Let's look at what we would do to retrieve the comments for a specific post. So we now have a sort direction that we can use to specify how we want to sort the information. And again, all I have to do here is call getPost and specify an ID. I then specified my selection set that I want to get to comments, and I wanted them sorted in descending order. So again, I get my comments from newest to oldest, and I know that they are going to be sorted based on the created at field. The third thing that I want to do is identify is-there relationships and reduce n+1 queries. So a lot of time, if you're using REST APIs, you may want to do something like implement universal search. So if you have a blog, you may have an input field where you want to search for anything that matches a certain term. So for example, on this blog, I want to search for all to post that matches a search term Q, but I also want to search for all to comments that matches the search term. So there's a couple of ways that you can go about doing that in GraphQL. The first thing that we want to do is you add another transformer to our type definition. So we had the add model transformer before. We want to use the add searchable transformer, which is a pretty powerful transformer. What this will do is that it will create an Elasticsearch cluster to which all of your changes to your DynamoDB table are going to be streamed. So anything that you write or update in your DynamoDB table is automatically going to be streamed to your Elasticsearch cluster. And that's going to make it really simple to search for terms in your Elasticsearch cluster, right? So DynamoDB is great for key value lookup, but not necessarily great for fuzzy searching. So we want to use Elasticsearch for searching. So one of the things that you notice is when I'm doing a search, the expectation is essentially that I'm going to get search results. So I can use the concept of unions in GraphQL to create a search result. And a search result is essentially specified as anything that is either a post or comment. And I can differentiate between a post or comment by using the type name. So one of the things that I can do is write a custom query and a custom resolver that returns a search result. And in my resolver, I can use a pipeline resolver, for example, to interact with multiple data sources and search for posts and for comments separately, but in one resolver, using a pipeline resolver. Or I can choose to simply use the search queries that are implemented by the searchable transformer. So I can write a query, for example, called search all, and in this query, request to execute search post and search comments. And again, these queries are generated because we're using the add searchable transformer. But I can have a single query from my application and specify that I want to do 2 searches and return the result from these 2 searches. So this allows you to reduce the amount of interaction that you're doing between your application and your GraphQL server. So what about subscriptions? Well, because we've moved to a GraphQL API and that we're using AppSync, subscriptions are implemented automatically for us. So all we have to do is use the subscriptions that are provided by the schema. We can use the onCreate, onUpdate, or onDelete, for example, subscriptions. And anytime that a mutation is made using AWS AppSync, any of our applications or clients that have subscribed for that change are going to get notified. So any change that is made using AppSync is essentially pushed to clients that have subscribed for those changes. So that is provided out of the box with AWS AppSync. This is essentially done using secure WebSockets to get the real-time notifications. The thing to remember about subscription is that they are granular, so you can request exactly the exact information that you want, or watch for specific changes. They are real-time, so subscriptions are triggered as a change is made, and they are done inline. So subscriptions really work well in a model where your application is essentially open and being used. In situations where your application is offline, you may want to use something like push notifications with Pinpoint to send notifications to your application. So what about fronting existing services? Let's say you have a situation where you cannot replace your existing API with an AppSync server directly. So this is what I did when I showed you the demo. I had a situation where we fronted the backend server with our GraphQL API. Let's look at how we can go about doing this. Again, this is straightforward to do using an existing API with GraphQL and with AppSync. AppSync supports multiple types of data sources. For example, we can link AppSync to AWS Lambda, or we can interact directly with HTTP backends using our HTTP data source. This allows us to connect with different types of services, private microservices living in your VPC or even living on-prem. We can interact with other GraphQL microservices, or we can simply interact with REST microservices as we saw in the demo. So what does that look like? How do we go about doing that? The first thing that you want to do is define the schema to reflect the data returned by your legacy API. So here we simply define a type of post and we specify the fields that make up the post. You can specify all of the different fields that are returned by your existing API. The one thing to remember is that you control what is returned to the client in the selection set of each operation. So you can cherry pick the fields that are returned to the application. And this can allow you to really reduce the size of the responses that you send back to your application and improve the end-to-end performance for your end users and for your application. Now, if you want to create the HTTP data source, it's fairly straightforward. You can go into the console and choose to create a new data source. Name your data source, provide a name. Here I'm providing HTTP API. Select the type of data source. So we want to do an HTTP endpoint. And then you simply want to select your endpoint, existing endpoint, and specify that in the endpoint. It can be HTTP or HTTPS. And then in your resolver, in your mapping template for your resolver, you want to map your REST components. So this is also fairly straightforward. You want to take your method and map that to the method in your resolver. For the resource path, you want to take the path that you use and map that to the resource path. And then into params, you want to take the query string and map that to query. You then want to take the body and map that to the body field here into params object. You can also pass all of your header information as needed to your backend API. So for example, you may have some specific authorization headers and some specific bearers that you want to send to your API for authentication and authorization. So you can do that here. And you can pass any type of additional headers that you want as well. A cool thing about AWS AppSync is that you can actually use the service to interact with other AWS services. So you may have a situation where you want to interact with a service like S3 or maybe a service like Amazon Athena, but you want to do this from your GraphQL service. You don't want your application to directly interact with those services. Well, you can call those services from AppSync by defining an HTTP data source as well. Let's look at how we do that. Here, I'm doing the definition using a CloudFormation template, and I'm creating a data source. So you see the type here is AWS AppSync data source, and I provide a couple of properties. The first thing I have to do is specify the service role. So we need to grant the AWS AppSync service permission to call this service on our behalf. So you have to provide a service role. and specify to role ARN here. We then specify to HTTP configuration. We want to specify to endpoint. Again, this is the endpoint. When you're dealing with a service, you want to specify to regional endpoint. So make sure you specify the right information depending on whether or not you're working in, for example, US East 1 or US West 2. We then specify to authorization config information. So this is one of the main difference between specifying a data source to interact with an AWS service and a data source that simply interacts with a regular HTTP service. We specify to authorization type. It's always AWS IAM in this situation. And then we specify the IAM configuration. So this is information that is going to be used to actually sign your request. So we need to specify the region here and the name of the service. You can look up the name of the service by looking up the documentation of the service online. And then you want to do a similar mapping in your resolver. Look up the type of method that you should specify to call the service. Map the path to the resource path. Map your query string to your query, and map your body information to the body. When you want to interact with an AWS service, there's a couple of things that you need to keep in mind for the headers. The first thing is the content type. You want to make sure that you specify the right content type. Most AWS services take in a content type application /xamz JSON 1.1. Look up to documentation for the specific service that you want to interact with to make sure that this is the right content type. The other thing that you want to keep an eye out for is XAMZ target. Different services use different headers, but a lot of services use the XAMZ target to specify which operation you actually want to take onto service. And again, you can look up the information and into documentation for the specific service to make sure you pass the right header information. But by configuring this data source and this resolver, you can now interact with any AWS service directly from your AppSync API. So a couple of things to keep in mind when you want to interact with HTTP backend. In your response mapping template, you can raise an error in case of an invocation error. So let's say you were not able to access the HTTP resource or some other type of error was thrown. You can actually check for that in your response mapping template. You can also check for the status code. So if the status code is not 200, which indicates success, if you're getting a 400 or 500 type of error, you can throw an error or formulate a specific response. When it comes to interacting with AWS services, make sure you understand the API and include the appropriate headers, as we saw on the previous slide. And especially watch out for the 30-second timeout when interacting with those services. AppSync has a 30-second timeout limit. So if you're interacting with a service that takes more than 30 seconds to respond to your request, make sure you pay attention to that. You may want to use a different type of model to interact with those services. For example, you may want to push or query for a specific action and then get notified after a certain period of time and push that notification to your application. The other thing to point out is make sure you use the selection set appropriately. Again, you can cherry pick the fields to reduce the response size. You do not have to send every single piece of information that is returned by your backend server to your application. So use the selection set to your advantage. So we just looked at a situation where you would want to interact with backend services using HTTP data sources. But there are some situations where you will have more complex situation, and you may want to use AWS Lambda instead. So what are those use cases? Well, you may have private APIs. So you may have APIs that live in your VPC, virtual private cloud. Or you may have APIs that live on-prem, and you want to interact with those services. And maybe you use a direct connect through your VPC to interact with those services. You may want to interact directly with data sources. So you may want to do direct data source access that is fairly complex and requires a bit of business logic. You may have complex authorization scenarios where you have to do dynamic authorization or provide dynamic keys to access your API. And then you may have situations where you have to deal with secret management. So maybe you're interacting with a database or a data source, and you need to dynamically retrieve the secrets to interact with that data source. So Lambda is a great tool to use in this situation, great service to use in these scenarios. Let me switch to a demo to show you how you can use AWS Lambda along with AWS AppSync. I also want to show you how you can use AWS Amplify's mock functionality to work directly with your implementation from your terminal. So let's take a look at how you can use Amplify to create data types that interact with AWS Lambda. So I'm in a very simple project that I created using to create React app tool. So this is my project, and it's actually an Amplify project. So I can do Amplify status. And I have my project created, and there's an auth resource that's been created. So this is a Cognito resource that's already been created. I want to create an API. So I can use Amplify add API. GraphQL, I want to call it local fresh. I want to say that I want to use Amazon Cognito user pool as my authorization type. And I already have a Cognito user pool created. And this is all I want to do. I don't need any additional configuration. Do I have an automated GraphQL schema? No. And I can have it guide me through some schema creation. And here we're going to choose to a one-to-many relationship type of application with blogs and posts and comments. And do I want to edit the schema now? I'm just going to select no. But what I've essentially done here is created an AppSync API using the Amplify CLI. So if I take another look at my status for my project, I have an API that I've created. I haven't pushed it to, I haven't created it yet. So I haven't pushed this to my backend. Then I'm going to call Amplify and do Amplify add function. So this will allow me to create a Lambda function. I'm just going to call it, use the regular name that it's provided, the function name, and it just says, I'm just going to do a simple hello world type of configuration. And then it's asking me now if I want to access other resources created in this project from the Lambda function. So the Amplify CLI can actually help me assign the right type of permission to my Lambda function to make sure that it can access different and other resources in my project. But in this situation, we don't need to do this. So I'm just going to say no. Now, do I want to edit the local Lambda function now? I'm going to say no. So I just showed you how to go about creating an API and creating a Lambda function. Again, I do Amplify status, and you can see that I've created the API to function, but I haven't pushed it yet. So let me switch over to a similar repo that I've created beforehand, just for the sake of time, and take a look at what we've have here. Same type of situation. I have my auth category that's been pushed to my environment, but I have API and function that's been created but not pushed yet. So it doesn't exist right now. I haven't created the API. I just have the definition, and I have the function definition as well, but I still need to create it in my AWS account. But let's say I want to start working with this API right away. So I can go in my schema, and like I said, I have a simple schema that's made up of a blog type, a post type, and a comment type that was created by Amplify for me. And so what I'm doing here, I'm adding a field called metadata, and I'm using the @function transformer to associate this field with a resolver that uses my Lambda function. So my Lambda function is called metadata fetch, and I specified the environment here because it was created with Amplify, so anytime I change my environment, it's automatically going to make sure that I use the right function, and it's just going to append the specific environment that I'm using. So now, anytime that I call metadata, that I want to retrieve the metadata field in my post, it's going to call my Lambda function to get the information. Let's look at the Lambda function implementation. It's a very simple function. It has a handler. I'm using the Axios library to retrieve information. And here, my Lambda function can essentially interact with any service, right? I'm doing a simple request to encrypted.google.com just to show that we can actually interact with an HTTPS API, and I'm getting to results. And then I'm going to log the result here to data from the response. And then I'm going to return this object with data1. So if you remember, I created a metadata type field of type metadata, and metadata is made up of a data1 field and a data2 field. So in my response, I'm returning an object with a data1 field. And I'm just saying metadata for the event. I can get the ID of the specific source, and I return the status. So how do I mock this in my environment right now? I can simply do amplify mock. And this is going to set up a mocked environment for me to interact with. So it creates resources locally. You can see that it's creating my tables, DynamoDB table, and then generates an endpoint for me to use. So I'm just going to click on this, and it brings this up. So I can directly interact with my local backend before pushing my application to the cloud. So let's say I want to create a post. Click on Create Post. The input, all I need to do is provide a title, new post, and what I want to get back is the ID, and let's say I want to get back the metadata, right? So this is what it returns. And take a look at the metadata field. Metadata for my ID, you can see that's the same ID, is 200. So it actually called my Lambda function locally. My Lambda function was able to make a request to my endpoint, and I've got the status code of 200. So I'm able to directly get feedback on my implementation by using the mock feature of the Amplify CLI. So this is something that you can use to quickly iterate and do implementation from your terminal before pushing your configuration to your AWS account. Let's go back to the presentation. So again, using AWS Lambda with Amplify. As you saw in the demo, the first thing that I did was to define the Lambda function with the Amplify CLI. And you saw how I did that. Amplify add function, then walk through the steps. It guides you and asks you the right question to make sure that you properly configure your API. And like I mentioned earlier, it also asks if I want to access other resources created in the project with the Lambda function. So I have a choice of specifying whether I'm planning on interacting with my auth category, my API category, or with other functions. And then that will then create the proper IAM permissions to allow my Lambda function to interact with those resources. I then define the field and use the add function resolver to associate the Lambda data source with my field. And this is what you saw earlier. So I have a metadata field associated with add function and simply provide the name of the Lambda function. And if the Lambda function was created with the Amplify CLI, you want to make sure that you provide this AND information here, because this changes based on the environment that you're using. Then implement the business logic into Lambda function. It's fairly straightforward. You can implement all your business logic here, and at the end of the day, you want to return an object that matches the expected field for the data type. Now, in case you want to do subscriptions with Lambda, you can also do that. So what you have here is a simple implementation that uses Amazon CloudWatch events to trigger a Lambda function periodically. So Amazon CloudWatch event is going to, using a specific rule, is going to trigger my Lambda function at a specified interval. I can then use my AWS Lambda function and specific business logic to check on whether or not something has changed in my data sources or with my private environment. And if something has changed, I can push a mutation using AWS AppSync and a non-data source. This enables a pub/sub type of pattern where I push a change that is not persisted in the data source, but that triggers a subscription. So using this method, I can actually trigger subscriptions to my clients using AWS Lambda and using CloudWatch events. And we have a couple of reference architectures that you can check out that shows you how to go about doing that. Now, as you start to migrate your API to GraphQL using AWS AppSync, or as you start to front your APIs with AppSync, you'll probably want to monitor performance to make sure that things are behaving as expected and to correct things that are not. So for monitoring, you can use the automatic dashboard feature for AppSync. When you go into CloudWatch and look at the different metrics, you can use the automatic dashboard feature to see 400 type of errors, 500 type of errors, and to see the latency for your different APIs. So this can really help you make sure that everything is behaving properly. You can also use the log insights feature with AWS AppSync. To use this feature, what you want to do is go into the settings of your API and turn on logging. Specify the service role that is going to grant AWS AppSync service permission to push your logs to CloudWatch logs. When that is done, you can then use Log Insight, and you can use some of the sample queries to get more information about your resolver performance. For example, you can find out your most frequently used resolvers, and you can track the latency of your different resolvers. And this may be important if you're fronting your REST API with AppSync. You want to make sure that you understand how your REST APIs are performing alongside AWS AppSync. What we did today is cover how you can upgrade your REST API to GraphQL using AWS AppSync, using the Amplify CLI, and using GraphQL transformers. Let me know what you think. My name is Brice Pele. You can get in touch with me at Brice Pele on Twitter. Thank you for joining us today.